Triangle congruence, angle side angle, angle angle side, and hypotenuse leg. Our objective is to apply angle side angle, angle angle side, and hypotenuse leg to solve problems, as well as prove triangles are congruent using angle side angle, angle angle side, and hypotenuse leg. Why learn this? Bearings are used to convey direction, helping people find their way to specific locations. Let's look at some vocabulary. We have an included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. So just like we had the included angle before and the angle was smushed between two sides, this is an included side, so it's going to be smushed between two angles. So side PQ works with both angle P and Q at the same time. It shares it. Let's look at the angle side angle congruence postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Let's try applying the angle side angle congruence. Let's determine if you can in fact use angle side angle to prove that these two triangles are congruent. Okay, well, they gave us that angle WXV is congruent to angle UXV, and they gave that to us. Well, let me fix the spelling on that one. Given. Okay, and then they also are showing us here that angle XVW and XVU are both going to be 90 degrees because you have a line, so if they're both 90, they're both congruent. So that is congruent to angle XVU. And for this one, we used the right angle congruence theorem. Because if they're both right angles, then they are both congruent. And now we need one more piece of information, and we can actually receive that because we know that XV must in fact be congruent to XV for that oh so famous reflexive property. So since we have corresponding angles are congruent, we have two of them, and then we have a side that's included, we can state that they are in fact congruent by angle side angle. Let's look at the angle side theorem. This is the only one that you technically need to prove. So if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. As a hint, you would use the third angles theorem and then prove that this is possible by angle side angle. And because the third angles have to be congruent in a set of triangles, and then you'd have the angle side angle postulate to back it up, that is why angle side actually works. So notice one of your angles and your other angle, the side is not included in between those two angles for it to be angle side. It is off to the side, not in the middle of the two of them. Let's try using angle side to prove triangles are congruent. So for this one, we're going to go back to practicing flowchart proofs. So we're going to do this one in a flowchart proof, so that way you don't kind of forget its existence. So we start with our given, and we have a couple of them. So we'll start with the fact that we have AB is parallel to ED. Didn't quite go all over it. There we go. All right, and we know that because it was given. And since they are parallel, that brings us to the fact that we know that angle B is congruent to angle D, and angle A is congruent to angle E. And both of them are using the alternate interior angles theorem. So the alternate interior angles theorem. Once again, you're dealing with things that are parallel with triangles. One of the things you want to look for is those alternate interior angles. Most of the time they'll be there. If not, try checking for corresponding angles when you're trying to write these on your own. Alright, well, we have another given, which kind of helps us out because we need it. So we have BC is congruent to DC. Let's see if I can get my box to kind of come out a little bit nicer than the last couple. And this was given. And now we use these three pieces of information together to give us our final statement. Because we need two sets of angles and a side. So we have two sets of angles and our side here. So now we have by angle, angle, side, since it said that we need to use angle, angle, side to do this. You could have done vertical angles and used angle, side, angle, but since it was asking us to use angle, angle, side, that's what we're going with. And we have triangle ABC is congruent to triangle EDC. And there's that proof. Let's look at one more. We have the hypotenuse leg congruence theorem. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. I like to think of this one as my checklist one. Okay, do we have right angles? Sorry, forgot a letter in there. Right angles. Alright, we're good. Do we have the hypotenuse? Or do we have some way of figuring out if the hypotenuses are congruent? Alright, and then do we have a leg? It doesn't matter which one. A leg in one triangle and a leg in another. Okay, so if you have right angles, a hypotenuse that's congruent in both of them, and a leg that's congruent in both of them, then you can use the hypotenuse-leg congruence. But you need to make sure you have a leg, a hypotenuse, and a right angle. You need all three of those, otherwise it's not going to work out. Alright, so let's determine if you can use the hypotenuse-leg congruence theorem to prove that these two triangles are congruent. If not, tell what else you need to know. Alright, so we have a right angle. So we've got right angles, and that would be angle DCB is congruent to angle ABC. So we've got right angles. Alright, do we have our hypotenuse? It's our next piece. Alright, well, we've got AC and BD, and they're congruent. So we have AC is congruent to DB. And so we've got ourselves a hypotenuse. And the hypotenuse, once again, is always across from the 90 degree, or the right angle. And then we need a leg. Well, we've got this shared side here. So that's a dead giveaway that you can use the reflexive property. So we had CB is congruent to CB for a leg here, and we use the reflexive property for that one. And that concludes our lesson on triangle congruence using angle side angle, angle angle side, and hypotenuse leg to shortcut a proof for proving two triangles are congruent.